Okay, so, all right, so this is the main software that's used for the GPC. You can access this from this menu, which should always be up on this computer. There's a selection that says Instruments. There's this desktop 7.6 Instrument 1. I think this is supposed to be denoting the HPLC, but I'm not sure because we haven't used that yet. But GPC system is what you're going to double click on, and it'll open this software, which is called Lab Solutions Real-Time Analysis, I think. Yeah, so if everything is set up the way I described to you guys for the detectors, and the detectors are on, the connections module is turned on and working, you're going to see LC ready at the top, which means liquid chromatography ready, which is what it calls the GPC. So we have our spectrum readout here in real time. So this is where you can kind of see what your baseline looks like. Right now, our UV baseline, which is detector A, quote unquote, in the software, for the 225 nanometer channel isn't looking great, but it's improving over time, so we just have to be patient with it. 360 is looking okay. It's pretty flat. It's a little bit below 0, but I'll show you guys how to zero this in a minute. So for just like your standard, we'll do just like a standard run. So down here we have our methods. Our method file is going to be denoted here, and we have several that we can choose from that myself or Apostolos or Keith have come up with. There's one called training, which was the original one I made with our Shimadzu rep to kind of just test the system. This is an okay one for you to use if you're looking for double wavelength, and also using the RI detector if it's working. So to assign a method to this space and send it to the instrument and let it know what to do, you would click on your method here in this sidebar, and you would drag it over down here, and you'll kind of get this little plus sign next to your cursor, and you'll just drop it. It'll ask you if you want to save the current one, depending on what it is, yes or no. I'm going to say no, and you're going to get a pop-up in a moment. Oh, it's not. Well, either way. Okay, yep, there it is. Okay, so this is the pop-up you'll get anytime you move a method into this section. It's called the method editor. So usually all these settings are already done for you. So for data acquisition, I usually do 60 minutes. That's pretty standard for a GPC run with our detectors. We have our two different detectors. We have detector A, which is UV, and AD2, which is RI. You can check whether or not you want them to actually be like checking your data. So I'm going to check both just for the sake of this training. Both of them, you're going to see a start time and an end time of 0 minutes to 60 minutes, which is great. You can increase that if you have a sample where you feel you need to, or you can decrease it if you have a sample that's going to elute really fast, just to save yourself time. So it's personal preference, but for calibration standards or for something you're not sure where you're going to see the sample, 60 minutes is fine. So this screen looks good. That's data acquisition. We'll move to LC time programming. This screen we generally just leave alone. You don't have to worry too much about this. The 60 minutes that we did in the last screen covers it. Detector A has its own window too. So there's a lamp option. If this is selected as D2, it means your lamp is currently on. You can actually turn it off manually this way too. The other way to turn off your lamp is to select a different method where the lamp is already off and pull that into your method screen here. So there's wavelength channels. You can actually put these in yourself. I believe it does not go below 200 and it does not go above, like, I can't remember. I don't know what the upper limit is, but I do know if you're doing 405 nanometers, you have to run that by itself for some reason. It won't allow you to run it simultaneously with another wavelength. So for the case of this, I usually just like to run the 225 and 360. Output, you don't need to worry about. This is our option for the recycle valve. So we have a couple options here. We can do recycle, drain, or recycle, drain. For a method where we're actually running sample through the GPC, this must be selected to drain because we don't want the sample going back into our new THF. Right. So that's good. You can leave that there. Controller. Generally, we don't really mess around with this too much. There's some advanced options here, like acquisition cycle time optimization. You can basically tell the auto sampler when you want it to pre-treat. It does it automatically already, so I'm not going to worry too much about this screen. There is an auto sampler window. This is where you would select that, yes, you are using an auto sampler, so you can keep that checked. You can also pick what rack you're using. We use the 70 vial rack, so that's always selected. Like I said before, the auto sampler is going to rinse the auto sampling needle. So what you need to do is select whatever volume you want it to rinse with. It's usually at 500 milliliters or microliters. There's no reason that I've meant to change that. It'll tell you how far down the needle stroke is going to go into the vial. You can change this if you want, but I kind of work around this by just making sure my vials are full to the top instead of having to worry about whether the needle's going to reach the vial. Sampling speed, rinsing speed, all of this is fine. There's also a purge time option. You can actually purge the auto sampler if you need to. I've never had to do this. I wouldn't worry too much about that unless we run into an issue with the auto sampler. Rinse mode, I personally like rinsing before and after. It does aspiration of the sample just to be thorough. Cooler temperature you can change if you want to. It's usually at 15°C. And rinse dip time, you want that to be sufficient so that the needle is getting a chance to rinse. So this is all like personal preference for the most part, but these are the recommended settings. There's one more window for auto purge. Like I said, we don't worry about this until we run into some kind of issue with the auto sampler, so don't worry about that. So download and close is going to download the method file you have selected to the GPC. So you're going to hit download and close. And a lot of times you can actually hear it click or beep, and you'll know that it's downloaded. It didn't this time because it was the same file that I had in there before. So this down here is all set up. It kind of shows us what our GPC diagram looks like. So we have our mobile phase, which is our THF. It'll show the auto sampler when it's actually working. It'll show these little animations so you know what's going on. You can purge and rinse manually here if you need to. Detector A, when this little light bulb is on, your D2 lamp is on. Just keep that in mind so we can preserve the lifetime of the lamp. And then AD2, which is our RI detector, because it is not Shimadzu, we don't have as many options in this particular software with it, but we can zero the input from here as we can with RI, or the UV detector. So we can actually, up in this real-time spectrum window, there's zoom in and out buttons. So you can zoom in if you want to take a closer look at what your baseline looks like. Like I said before, our RI detector is really drifty, so I'm not going to worry too much about that right now. I'm going to zoom in, for example, on my UV detector. My 360 baseline looks really good. Look how flat this is. But my 225 is still a little messy, but its noise is below 1 millivolt, which is great considering it was up above like 25 a couple days ago. So if you ever want to examine your baseline, this is the best way to do it, or see if you're getting any drift. I'm going to zoom out, and while I set up our batch, I'm going to actually zero both of the detectors and let those kind of get back to zero. Do that here. And sometimes you'll see a little bit of this change up in the window, so you'll see this actually will go back to zero. There you go. And then we can zero AD2 as well. This probably won't work right now because our RI detector, it does come down, but it will drift back up. It's really struggling. It's not having a good time right now. So just focus on UV for now. Okay, so you have your experiment set up. You've chosen your method that you want to use. The next thing you want to do is you want to program your samples. So if you go down to the bottom left here, we're in the data acquisition tab. We want to go to the real-time batch tab, and this is where you're going to put your samples in. So these are the samples I'm going to run today because I'm still trying to calibrate the GPC and get the baseline stabilized. And I have named them red, yellow, and green standard because that's the cap colors, and then I can tell from the cap colors what the molecular weight is because I have this little sheet that's going to help me out. So you can name your samples whatever you like as long as you know what they are. So for example, say you have 20 samples and each one is a different monomer and you don't want to put the name in, you can just put 1, 2, 3, 4, 5, whatever, and just write it in your lab notebook or put it in the file, whatever you want to do. So when you fill these out, I just go left to right. So you want to put in your vial number, which is going to be labeled on the tray that I showed you guys earlier. It's going to be 1 through 70. I usually try to start at the lowest number so I can just keep track of my samples. We saw that my red standard is indeed in vial 1. So this is good. The tray name for the big tray is tray 1, so you can leave that the same for all of your samples.
And number 2 is the small.
Yes, number 2 is the little long tray that I showed you before, and we can use that for any standards that last a really long time, and we just want to keep them in there so we can run them every couple months or whatever. You can choose the standard or the sample type by clicking this little downward arrow. So there's a bunch. Usually if you're doing just like a regular sample, you would do an unknown. You can do a standard where it would initialize a calibration curve after. I'm going to make a separate training video for that because that's still something that I am struggling with too, and I need to reteach myself how to do that. There's control, unspiked, spiked. It really depends on what your sample is, but the 2 that I use most often are standard and unknown. So these are standards. So I'm going to select that, hit OK. For method file, that is the file that we are using that I showed you before that tells the GPC what to do. So you can select that from these different files actually in the computer. So for me, I'm using training. It's already in there. Otherwise, you would click it and select it. And then data file is where your data is going to go. So I'm going to open that. This is my folder. I'm going to make a new folder for today, which is the 16th of September. I'm going to open it. I'm going to call this red standard. And then you hit open. So it will show you a new pathway as to where your file's going. Level number 1, I actually am not sure what this does, but I do know leaving it at, I think it has something to do with the auto sampler, but it's always going to pre-program it as 1, and that's fine. Injection volume is in microliters, so generally there's no need to change this. 10 microliters is plenty for our purposes. So I did the same with my other samples for vials 1, 2, 3. Red, yellow, and green standards. I now just need to change my pathway for each of these guys. So I'm going to go in here. We'll call it yellow standard. And then save this one to my new folder and call it green standard. Cool. Okay, there are 2 more rows here that are always going to be present, and their vial number is going to be called -1, which tells the system this is not an actual vial, but an action that we're going to be asking you to do. So -1 will always go in the vial number for these 2 rows. Tray name will be 1. There's a drain function and a recycle function. What this tells the GPC to do is once the sample is finished and the 60 minutes is up, or however many samples you have, it's going to drain into waste for 10 minutes just to pump everything out, and then it's going to switch to automatically recycling. So the great thing about this is, say you have 10 samples, which takes 10 hours. You can come into lab at noon, and you don't have to come back here at 10 p.m. to switch the solvent back into recycling. The instrument will do it for you. So that's the really nice part about these functions. The method files are a 10-minute drain file and a recycle file, which have already been built. Data files, there has to be a data file, so these will save into these like little .lcd files. You don't have to worry about any of that, but just make sure that these are programmed in. Otherwise, it will not recycle the solvent, and you're going to be wasting a lot of THF. So that's everything for samples. If you need to insert more rows, you can do that by right-clicking and then saying insert a row, and it'll put a new one in for you. It'll keep the same method file, and it'll keep the same sample type. You just have to fill everything else out. So I'm going to delete that guy. and this looks good. So let's go back to data acquisition. Let's take a look at our baselines. So yeah, our RI detector is still really drifting, but our UV detector looks okay. Our 360 line looks really good. 225 still looks better, but it's more on 0 now, which is what we were hoping for. So final step is we want to go back to real-time batch. We want to select all of our rows, including drain and recycle. And then there's a button over on the left that says Start Real-Time Batch. So you can hit this play button, and I selected all the rows, so it'll ask you, oh, do you want to execute all rows or just your selected rows? Since I selected them, I'm just going to hit selected rows, and I'm going to hit Start. It says current batch file will be saved to run batch processing. It's just letting you know that it's doing a batch. You hit OK. Save current method file. We didn't make any changes to it other than the RI detector being turned on. So I'm going to say to save it just because I want it on, just for the sake of the training. It'll give you a wheel for a second. And then acquisition is disabled for all detectors. Are you sure you want to continue data acquisition? For 10-minute drain and the recycle, it's not collecting any data, so that makes sense. So that's okay with us. We can say yes. So we'll say, please wait. It kind of gets itself together for a second. And then you'll see this LC start to say pre-treatment, which is where the auto sampler down on this little animation is going to show us that the auto sampler is rinsing itself. Pre-treatment, I usually, when I start my run, I like to wait until this says running before I walk away, just in case there's an issue with the pre-treatment. So we'll just wait a moment. So then we'll see our spectrum will go away, which is normal, and then it'll say running, and it'll start from 0. So now you can see the run in real time, and then now is the time when you would be able to walk away from the instrument, and it would just start running. So I'm going to stop the training video there, and then when we do data analysis, we'll make a separate video so that we don't have to just let this run for an hour.